So we are going to be starting a new section, but before we do that, we're going to review a little bit three sections that have come before where we are right now, because it's important to remember what we learned in those sections, because we're going to be applying that knowledge today. So the first section I will refer to, we covered in chapter 2 about a month before the end of the trimester, and we had problems that looked like this. So for example, 3x equals 239. We covered these problems. These were single-step equations, and the idea in single-step equations was to isolate the variable. And no, you don't have to write this. Now, when I say isolate the variable, I want the variable, in this case the x, to be all alone on one side of the equation, and I want nothing else on the same side of the equation. So I want to get rid of that 3. How do we do that? How do we get rid of that 3? Well, we use inverse operations. Remember those? They were the opposite of what's being done. So right now, the x is being multiplied by 3. What is the opposite of being multiplied by 3? It's to divide by 3. And can I just leave it like that? No, I can't. Because if you remember, whatever you do to one side of the equation, and it's an equation because it's got an equal sign here, I have to do to the other side as well. So if I'm dividing one side by 3, I have to divide the other side by 3 as well to keep the equation balanced. And over here we have 3 divided by 3, which is just 1. So x equals to 39 divided by 3, which in this case was 13. Now, how do we verify that 13 is the answer? Do you remember how to check your work? That's correct. You want to take, or I hope that's correct, you want to take the 13, plug it in, our solution, you plug it in into the equation for the variable, and then you solve it. 3 times 13 is indeed 39, which works out. Good. Let's try another problem that looks like this. All right, terrific. Same concept here. We have a single-step equation, and in this single-step equation we're isolating the variable z. To isolate the variable z, we need to get rid of everything that's on the same side of the equation. So what do we need to get rid of? The minus 100. What is the opposite of minus 100? Correct, I hope. Plus 100. Just to one side or to both sides? To both sides, of course. All right, terrific. So now that we've done this, minus 100 plus 100, that's gone. And on the right side, 24 plus 100 is 124. And once again, you can easily check your work by taking your solution, the 124, and plugging it into the z here. 124 minus 100 is indeed 24. Works out. And please, please, please do not force your checks. Do not make the problem check out if it doesn't seem like it's checking out. That means it's telling you you did something wrong. If you're forcing your checks, you're not doing anyone any favors. All right, let's do 2 more problems for review. Now we're going to do something a little bit, I don't want to say it's tougher, but we learned this one section after we learned single-step equations, and these were our 2-step equations. So let's say I have 11. Let's see. Plus 5w equals to, let's see here, 46. All right, so this is a 2-step equation. What makes it a 2-step equation? the fact that we have two things that we need to get rid of before we can isolate the variable, in this case w. I have this 11 and I have this 5. I need to get rid of them both, and I do them one step at a time, hence a two-step equation. The only challenge, if there is one here, is to figure out which one to get rid of first, the 11 or the 5. So which one do you think I should go for? This or this? If you remember this section, you should have set the 11. Why? Because the 11 is the further away term, and you want to tackle terms that are further away first, kind of like peeling an onion. You go for the outer layers first and you work your way in, and the W in this case is our core. So the 11 is being added to the W, the 5W in this case, but the 11 is being added to our W term. So what's the opposite of adding 11? It's to subtract an 11. And of course, I can't just leave it like that. I have to subtract it from both sides. Alright, cool. Now what we have? We have an 11 minus 11, that's gone. 46 minus 11, that's 35. And I still have this 5W11, which just drops down. Perfect. Now it's just like this problem here. You took care of one step, you only have one step left. You just have to get rid of the 5 times. What's the opposite of 5 times? Divide by 5, of course. On both sides, don't forget. So of course on the left side, 5 divided by 5, that's gone. It's not gone, it's a 1. But 1 times anything, the identity property, we ignore it. So then we have W on the left side, and what's 35 divided by 7? 35 divided by 5. I just told you the answer, 7. That happens. Whoops. So this was a review of what we did before the trimester, and the reason I'm showing this to you is not because I just want to bring back some random section that we covered before. It's because we're going to be using what we learned here in the lesson that we're going to cover today. So hopefully this refreshed your memory. Now let's do one more review problem. This one is a bit closer to what we did. This is a problem from the previous section, 3.2, so I'm hoping it's very, very fresh on your minds right now. So let's give you an example. Let's say we have 3x plus 5 plus 4x minus 6 minus x. Alright, so I'm hoping this is not a new problem to you right now. You're looking at it and going, hey, I just did a problem like this not too long ago, so I should be good to go. And I'm asking you to simplify this problem. So to simplify this problem, all you have to do, what do? Combine your like terms. I have 5 terms here, 1, 2, 3, 4, 5, and I have 2 different terms types. What are those term types? X term and a constant. So let me visualize them. X term, X term, X term. And now let's visualize the constants. Constant, constant. And if you remember from the last section, you can combine any like terms. So the x terms are like terms, the constants, terms without variables, are also like terms. So you can combine these 3, you can combine these 2. Let's do that. 3x plus 4x, what is that? 7x, right? You have 3 x's, you add 4 x's to them, you get 7x. 7x, take away an x, you get 6x. Three x plus 4x is 7x, take away an x, 6x. Hopefully that's not a problem right now, everyone is okay with that. And then with the constants, 5 minus 6. 5 minus 6. It's going to be a -1, so -1. If you are still a little bit shaky on section 3.2, I highly suggest you watch my 2 videos on 3.2 because you need to be pretty solid with this section if you are to be covering the materials in this section that's coming up. So again, that's the answer. Fully simplified, we combine our x terms and we combine our constants. Alright, now let's move on to the lesson itself. So as the title suggested, we're dealing with multi-step equations. And multi-step equations are equations that have more than one step. Technically, two-step equations are also multi-step, but we consider multi-step anything that requires more than 2 steps. So if an equation requires 3 steps before you can solve it, it qualifies as a multi-step equation. They're very similar to two-step equations, but sometimes there's something additional that you need to do before you can go on and isolate your variable. So let me give you an example. And you need to write this down as I write it. So we have 8x plus 6 plus 3x minus 2. And all of it equals 37. And I just asked you to solve this. Not simplify, like I did in the last section, but actually solve. So write this one down. I'll give you a little bit of time. Alright, so you're looking at this problem and it looks familiar, hopefully, but it also looks a little different. You're seeing parts that you've seen before, but you haven't seen this combined into one big whole yet. First of all, we have an equal sign, which makes this an equation. You also have variables, so you have algebraic expressions here. And you have 2 things combined. You have the section 3.2 material here, where you're going to be simplifying and combining like terms, but you're also going to be dealing with equations where you have to isolate the variable, something we'll learn in chapter 2. So first things first, in any equation, I want to isolate the variable. In this case, I want to isolate the x. I have a problem. I have 2 of those x's. What can I do? So hopefully someone in the class said this. Combine like terms. And that's the first thing you want to do because you have terms here that are of the same type and you can simplify those. So even though this is an equation, you can apply what you learned in the last section to simplify like terms here. Alright, let's do that. We have on the left side of the equation, and when we simplify terms, we only do it on whatever side of the equation we're working on. So you can't mix the 2 sides of the equations. Think of the equal sign as like a wall that separates both sides. So on the left side we have 4 terms, 1, 2, 3, 4, and 2 different term types. What are those 2 different term types? We have an x term, and a pair of constants. So you have a pair of x terms, but you also are working with a pair of constants. Technically this is also a constant, but because it's on the other side of the equation, we're not going to worry about it because we can't mix it in anyways. So it's just going to stay there. Although that's a constant, 37 is a constant too. Alright, let's combine our like terms. This should be easy. 8x plus 3x. What is that? Alright, good. 11x. Constants now. 6 minus 2. What is that? Alright, so we combined our like terms. Perfect. We still have the equals to 37. Now this should be pretty simple because we just made a two-step equation here. This is a very simple two-step equation where you're going to be isolating for the variable x, and you have two things that you need to do before you isolate it. Get rid of the plus 4, get rid of the times 11. So which one do you want to get rid of next? Hopefully everyone just said get rid of the plus 4 because that's the further away term. Sorry. You want to tackle the term that's further away first. So I'm going to get rid of the plus 4 first. And what's the opposite of plus 4? That's right, minus 4. And remember, do it to both sides. Plus 4 minus 4, that's gone. It's plus 0, but we're going to ignore that. 37 minus 4, well, it's 33. Alright, perfect. Now we have one step to go. Our variable, the x, is still not isolated, still not alone. How do I get it to be alone? Get rid of this. It's times 11. What's the opposite of being multiplied by 11? Divide by 11. On both sides, of course. So 11 divided by 11, that's just 1. Identity property, we don't have to worry about it. So now on the left side, we just have an x. What's 33 divided by 11? And you can easily check your work by plugging in the solution into the x's or the variables here, and you should get 37 at the very end once you crunch all your numbers. But that wasn't so bad. That wasn't so bad at all, and it's good that it's not so bad because it's going to get a little bit tougher. But before we move on to something that's a little bit tougher, let's do another problem of this very same type. Alright, that's the next problem. Yes, you do need to copy this down. So go ahead and copy down. I'll give you a little bit. Alright, so enough time to write it down. Let's go ahead and solve it. And yes, you do need to solve this, not just simplify. So just like the last problem, what should you do first? What will be your first step? Combine like terms. Someone should have said that, hopefully. So you need to combine like terms. What are like terms here? We have an x term here. We have an x term here. Any other x terms? Nope. We also have a pair of constants. Constant. Constant. It's also constant, but again, we're not going to worry about it because it's on the other side of the equation. It's kind of like separated by a wall. So we can't combine it with anything at any rate. Unless there's something else on the other side of the equation. Later on, we will look at problems where you actually have other things on the other side of the equation where you can also do some combining there. But in this case, 42 is flying solo. Nothing there for it to do. It's just gonna just hang out and just, you know, be there. All right, now let's go ahead and combine our like terms. With the x's, I have 9x's plus 4x's. How many x's do I have in total? 13. Constants. 5 minus 2. And remember, the sign belongs to whatever term it's in front of. So I don't have to worry about this plus because it belongs to the x term. I already dealt with the x terms. So 5 minus 2 So that's a 3. All right, great. I combined my like terms. So now, and I still have it equal to 42. So now I need to isolate the x, the variable. Two-step equation. I'm going to tackle the one that's closer or further. Hopefully everyone said further. It's plus 3. What's the opposite of plus 3? What's the inverse operation? Minus 3. Perfect. So plus 3 minus 3, that's gone. It's a 0. 13x equals to 42 minus 3. That's 39. All right. Good. One step away from solving this problem. The last step, we need to get rid of this. Multiplied by 13. The x is being multiplied by 13. What's the opposite of that? Divide by 13 is the opposite of multiplied by 13. And again, to both sides, of course. 13 divided by 13, that's 1. I'm going to cross them out. The 1 is still there, but 1 times x is x itself, so identity property, I don't have to worry about it. 39 divided by 13, if that's not obvious, so hopefully it is, but if not, that's just a 3. And that's it. We have this solved. And if you want to make sure that that is the right answer, you can take your solution to the x, plugging in into the x's here, both of them, not just one. So you have to plug in the 3 here and the 3 there, and then do your multiplication, do your addition, subtraction, and you should end up with 42. If you do, you have the right answer. If you don't, go back and fix it. So next we're going to tackle a few problems that are a little bit tougher than what we've covered so far. They're not too bad, but they're a little bit tougher. First of all, apologize for the flashlight glare. That's my light source, so can't be helped. But now things are going to get a little bit more fun. So remember I told you what we did before was the easy part. Now this is the slightly less easy part, because I've introduced fractions, rational numbers, and of course when fractions are around, things become more fun. At any rate, how do we solve a problem like this? Well, this is a multi-step equation because it requires more than 2 steps. Specifically, you need to get rid of 3 things in order to isolate the variable n. I want to give you a little bit here, and I want you to figure out what are the 3 things that I need to get rid of in order to isolate the n, because remember my whole point here is to solve this, and to solve this I need n to equal to something. So how do I do that? Tell me the 3 things that I need to get rid of. Alright, so hopefully you came up with this, the 7 over 4, the divided by 4, and multiplied by 5. There was the 3 things that you came up with as far as what I need to get rid of in order to isolate the n. And if you did so, you're absolutely correct. 3 things, 3 steps, thus it's a multi-step equation. Now the fun part here is that normally you would get rid of this guy first, because I've taught you to get rid of what's further away. And you could do that. You would actually eventually get the right answer, but it becomes messier, because if you get rid of this one, on this side here, you'll be dealing with fractions. And fractions are not always the easiest to deal with, as you've probably figured out so far. So here we're going to break our rule a little bit, and we are not going to get rid of this first. What we're going to do instead, we're going to get rid of fractions altogether. Because what makes all 3 of these fractions is the denominator here, the divide by 4, the bottom portion. Lucky for us, all three terms here, again, since they all have the same denominator, which is 4, I can get rid of it. It's the same denominator. So if I can get rid of that denominator on one of the terms, I can get rid of it on all of them. And that would be the easiest way to go about this problem. Again, you could technically, if you really wanted to, and in class you can stop me and I can show you how that's done if we have the time, where I get rid of this first and then I move on from there. But that's messy. So instead, I'm going to get rid of the fractions. How do I do that? Because they all have the same denominator, I'm going to choose any one of these. Let's say this one. And I want to get rid of this divide by 4. How do I get rid of divide by 4? What's the opposite of divide by 4? Correct, multiply by 4. And I'm going to multiply everything by 4, which I kind of have to. Remember, if I'm going to multiply anything in an equation, I got to multiply everything. So I'm going to multiply the left side and the right side by 4. So I'm going to multiply everything here by 4, and I'm going to multiply everything here by 4. Now this isn't new. I can multiply both sides of the equation by anything that I want. As long as it's the same number and it's the same operation, I'm good to go. Why did I choose to multiply by 4? Well, because divide by 4 and multiplied by 4 are inverse operations. They're opposites. They cancel each other out. So let me go ahead and distribute. So I want to distribute this 4 into both members of the parenthesis using distributive property, which is going to net me this. I'll fill in the rest in just a second. Looks a little empty right now. So I'm going to multiply 4 by this. I'm going to multiply 4 by that. Running out of space. And of course I need this multiplied by 4 as well. So essentially I multiply everything by 4. Now because they all had the same denominator, this happened, which is kind of neat. Multiplied by 4, divide by 4, cancelled. Multiply by 4, divide by 4, cancelled. Multiply by 4, divide by 4, cancelled. All my divide by 4s are gone. What's left is 5n plus 7 equals to negative 3. So again, I had fractions. The fractions were all devised with a denominator of 4. I was dividing by 4 in every single case. I got lucky. They all had the same denominator. So I can get rid of all of them in one swoop by doing the opposite. If I'm dividing by 4, what's the opposite of divide by 4? Multiply by 4. So if I multiply this equation, and remember in equations, if I multiply something, I got to multiply everything, both sides. They all go away. All my denominators go away. So if I multiply left side by 4, right side by 4, I distribute the 4 on the left side to both terms there. That's it. No more denominators, and now I have this. Well, this is a lot easier to work with. This is a two-step equation, and we've done plenty of these. Now you want to get rid of this first. So because it's further away, we're going to get rid of the plus 7 first. So what's the opposite of plus 7? Right? Minus 7 is the opposite of plus 7. To both sides, again, this is gone. And on the right side we have negative 3 minus 7. Hopefully, by this point in time, you're not surprised and you understand why negative 3 minus 7 is negative 10. You start at negative 3, on the number line, you go left 7 units and you end up with -10. Alright, at any rate, so one more step to go. Not just get rid of 5. It's multiplied by 5. What's the opposite of multiplied by 5? Divide by 5. And of course on both sides. Alright. Gone, gone. Or simplify to 1, so there's a 1 in there, but again, identity property. -10 divided by 5 and is -2. And that's it. We have n equals something, so we solved it. But you know, if you solve this correctly, you can plug in your solution, the -2, into the n right here, and then crunch your numbers. And it should equal out to this. Yeah. All right, let's do one more example here. All right, so here's another example. It's pretty similar to the problem we worked on just a little bit ago. Same concept applies. This is a multi-step equation because we need to get rid of 3 things in order to solve this equation, to solve for n, to isolate the variable. And it's n again. So, you know what, for fun, let's make this into an m. So it's not the same variable. And yes, make sure you copy this down. And after you copy it down, again, look at it and tell me what are the 3 things that we need to get rid of in order to isolate m. One, plus 5 over 6. 2, divide by 6. 3, multiplied by 3. So 1, 2, 3 things that I need to get rid of in order to isolate my variable here, which is m. So again, if you really wanted to, you could get the further term right off the bat, get rid of it, and it would work eventually, but this is one of those cases where this is going to create more work for you. There's an easier way. All fractions all have the same denominator. We are going to get rid of this denominator for all of them. So we're going to convert all of these fractions into non-fractions. Again, since they all have the same denominator, it doesn't really matter which one did I choose. I'm going to choose this guy right now because, again, it doesn't really matter. And I'm going to get rid of its denominator. Right now it's being divided by 6. Right? The -1 is being divided by 6. How do I get rid of divide by 6? I get rid of divide by 6 by doing the opposite, which is multiply by 6. Inverse operations. So I want to multiply this by 6. Good, good. First step. And remember, whatever I got to do to one side, I have to do to the other side as well. I'm going to multiply the entire left side, not just one or the other, the entire left side, by 6 as well. Alright, so before I go on any further, I need to distribute this 6 to both terms. Ahead of time, if you don't want to, you can multiply this 6 individually. You can kind of skip the step here, the distributive property step. But in case that still doesn't make a whole lot of sense to you and you want to go this route, you can. All I'm saying is you can actually skip this step and have the 6 be multiplied by each term on the left side individually from the get-go. At any rate, when you distribute, you get this. Six times 3m over 6. So I'm just distributing my 6 now. 6 times 5 over 6. And then, of course, 6 times my -1 over 6. So again, I'm getting rid of my denominator by multiplying the entire equation by 6. Remember, I can multiply this equation by anything that I want, as long as I do to every single side equally. So I decided to multiply by 6. Why? Because multiply by 6 and divide by 6 are opposites. And if I can get rid of divide by 6, all the fractions are gone. Magic. That's also math. All right, multiply by 6, divide by 6. 1 6 in the top, in the numerator, 1 in the denominator, cancelled. 6 in the numerator, 6 in the denominator, cancelled. Same thing, cancelled. So what am I left with? I'm left with 3m plus 5 equals to -1. All right. Now this is a two-step equation, which should be pretty easy to solve. So let's solve it. I have two things to get rid of. Which one do I go for first? This one. Because it's further away. I'm going with the standard rules now. Alright, so plus 5 minus 5, that's gone. And here I'm left with 3m equals to -1 minus 6, the same as -1 plus a -1 minus 5, which is the same as -1 plus a -5, end result -6. Again, if this doesn't make sense, think of the -1 on a number line, and then you have to go left 5 units on the number line. So if you start at -1, you go left and you go left because the other number is negative. So if you go left 5 units, you're going to end up at -6. All right, so last step, because now we only have a single step equation here. I want to get rid of the multiplied by 3. What's the opposite of multiplied by 3? Divide by 3. Three in the numerator, 3 in the denominator, cancelled, or simplified to 1. There's still a 1 there somewhere. So m equals to -6 divided by 3, -2. And it's a -2 because we have a division of two rational numbers or integers with different signs. Different signs yields a negative number always. Alright, so that was the second example problem. Next we're going to look at something that's a bit more difficult, but not too bad, not too bad. Okay then, so this is going to be the last problem that we're going to work on for this lesson. And I've saved the best for last. It looks a little bit tough when you're looking at it right now, and it's not too bad, but yes, this is the most difficult problem we've tackled so far because there's a lot of things going on here. You have two variables there. They're the same variable, which is always nice, but there's still two of them. You got fractions, and if you notice something different from the last set of problems we did, the denominators are not the same. Yeah. So write this down. Just like the last problem though, the easiest way to go around and solving this problem, and we do need to solve it, is to get rid of all of the denominators. Make these fractions go away. Let us deal with just integers and the variables and no fractions. Now it's a little bit more difficult than last time because last time they all had the same denominator. If you got rid of one, they all went. This time that's not the case. This time they don't all have the same denominator, which is a bit of a problem. So how do we do that? How do we get around to get rid of all of the denominators? Well, the first thing you want to do is find what is the common denominator that they all share. Remember that term, common denominator, from way back in chapter 2? Well, it's coming back. Now, one way you can find the common denominator is your cue to tell me. Right, it's to multiply every single denominator, and you'll get something that's common for sure. But here, 9 times 2, that's 18, times 9, that's big, times 3, that's even bigger. You're talking about one of those big, chunky denominators. Or you can find the LCD. Remember that? Yes. And we're going to do that. We're going to find the LCD for technically only 3 denominators here, because here I have the 9, the 2 9s are the same, so I only have to find a common denominator for the 9, the 2, and the 3. I'm going to start with the 2, the smallest. So I'm going to list off all of the multiples of 2. 2 itself, 4, 6, 8, 10, 12, 14, 16, 18, and 20. Now I'm going to list off all of the denominator or the common multiples of 3. So I'm going to go with 3 next. I'm going to keep them different colors so they're easier to see, I suppose. Alright, so with 3 I have 3 itself, 6, 9, 12, 15, 18. I'm going to stop at 18. You probably already see a pattern. And last but not least, I'm going to go ahead and tackle the 9. And the multiples of 9 are 9 itself, then 18, then 27, but I'm going to stop there because hopefully you already see the pattern. Specifically, I'm looking at this number. It's something that they all have in common. This is their least common denominator. There is no denominator that's smaller. So how does that help me? Do I want to convert them all to have the LCD? No, because I'm trying to get rid of the denominators altogether. I'm not trying to make them all common. My plan is to get rid of them all. And the best way to do that is to multiply the entire equation by the LCD. You're probably thinking, now you lost me. Well, bear with me here and I'll show you why. So I'm going to multiply the entire equation by 18, which is my LCD. So I'm going to multiply this by 18 and I'll multiply this by 18. So again, bear with me here. Let me distribute this, and I promise you there is going to be a reason to the madness. I hope. So distributing, I'm going to write out the terms first, and then I'll write in the actual multiplication. Okay, so when I distributed the 18, I got 18 times this, 18 times this, 18 times this, and 18 times this. Okay, what's next? Well, we're going to multiply. But before we do that, I'm going to break down the 18 and anything else that I can to help me out here. Breakdown, you say? That sounds vaguely familiar, also kind of scary. Yes, this is something we covered in section 2. One of the last sections of chapter 2 that we covered. 2.6? Yeah, something around there. So I'm going to break down the 18 into 2 times 9. And 9 is 3 times 3. So let's see if I have enough space. 2 times 3 times 3, that's 18. The 7 I can't really break down into anything, so I'm going to keep it as is. It's 7 times x. The 9 I can break down into 3 times 3. plus, I'm going to do the same thing here. It's 18, so it breaks down into this. The x I can't break down into anything. Again, I have the 18 here. So that's 2 times 3 times 3. And I apologize if this is starting to look a little small. Running out of room. The 17 is prime, can't break that down into anything. And on the bottom, it's a 9, so that's 3 times 3. All of this equals to 2 over 3, can't break 2 or 3 down. And of course, the 18, I can break it down into 2 times 3 times 3. Alrighty then. That looks messy. It's not so messy. It looks complicated. I'll give you that. It's a bit complicated. So, cancel time. I can cancel things out. Remember, if it's the same thing on the top and the bottom. Okay, so let's see what we can cancel out. Let's see what we can cancel out here. I have a 2 on the top, no 2's on the bottom. I have a 3 on the top, 3 on the bottom. 3 on the top, 3 on the bottom. And if they're separated by a plus or an addition or a subtraction, I can't mix them up. So that's all I can do here. I'm going to look at this collection of terms next. I have a 2 at the top, a 2 at the bottom, a pair of 3's at the top, no 3's at the bottom. That's it. Here I have a 2 at the top, no 2's on the bottom, but 3, 3, 3, 3. Here I have 1 3 at the bottom, 1 3 at the top, and that's it. After I did all my cancellation, let's see what I'm left with. 2 times 7x plus 3 times 3, which is 9, times x. Nothing on the bottom, nothing on the bottom, minus 2 times 17, nothing on the bottom, equals to, oops, I forgot to, with that 3. So 2 times, and that's 2 times 3, which is 6. Now, what did this accomplish? What was the big deal here? What did I get rid of? So I'm going to give you a second to figure that one out. No more denominators. That was the whole purpose here. What was a very simple step before became into something a bit more complex. And yes, this is a more complex problem. But essentially, the whole goal here from the get-go was to get rid of the denominators. Here, because they had different denominators, it took some extra work. I had to come up with the LCD, I had to multiply everything by the LCD, and because they have different denominators, they're not all gonna cancel out in the same manner. So I had to go and cancel each one out individually, but eventually, the whole goal here and the whole purpose and my mission is accomplished, at least my first step. No more denominators. Now I just have that to work with. Alright, so next step. I'm going to go ahead and do my simplification here. 2 times 7x, that's 14x. 9 times x is just 9x. Negative, or just minus, 2 times 17, that's 34. The minus is still there. 2 times 17 is 34. And over here, I have 12. Gonna get rid of this. This goes up. All right. Now I'm almost there with a two-step equation, except I can combine some like terms. X term, constant, constant. Can't combine these constants, they're on different sides of the equation. There's like a wall blocking them. But I can combine these two x's. They are on the same side of the equation. They're like terms. They're the same term type. So I'm going to go ahead and combine them. 14x's plus 9x's. I have a grand total of 23x's minus 34 equals to 12. All right, two-step equation now. Isolate x by getting rid of this and this. And I'm going to tackle the one that's further away, which you should too. What's the opposite of minus 34? Plus 34, inverse operation. And of course, to both sides. Okay, perfect. Minus 34 plus 34, that's gone. It's a 0 now. And I'm left with, on the left side, 23x. On the right side, 12 plus 34, that yields a 46. Alrighty. Last step, single step equation now. I need to get rid of this 23. It's being multiplied onto the x. What's the opposite of multiplied by 23? Divide by 23. Both sides, please. To keep everything nice and even. Alrighty, home stretch here. Multiply by 23, divide by 23, that cancels out to 1. There's still a 1 there, but we're going to ignore it because anything times 1 is itself. So we just have the x there. And 46 divided by 23, if this isn't, if you can recognize that, it's just a 2. 23 goes into 46 twice and it goes into that evenly. Alright, answer. Finally, after all of this, we get to the answer. Will you have a problem like this on the quiz? Maybe. I may put a problem like here. Yeah, I'll probably put one up. Maybe not. Maybe one that's a bit easier, but still a problem where you have different denominators and you need to get rid of them. So you probably will have to go through an LCD or at least a common denominator method. But there's only going to be one of these on the quiz itself. Might be an additional one as an extra credit that's maybe a little bit tougher. But yeah, I'm not just doing this for fun. And again, we didn't do anything here that we haven't learned so far. In the previous examples, we talked about getting rid of the denominator, except here it took us an extra step using common denominators, something that we learned before. So that's nothing new. Getting to that 18 wasn't anything new. Doing this, canceling out or simplifying numerators and denominators, that's also not anything new. So it was a compilation of a lot of things that we learned over this year so far. So yes, expect something like this, maybe a little bit easier, but still similar to this on the quiz. Maybe just one of the problems, but still. So if you have any questions, good time to ask me now, where you're going to be working on a worksheet which has problems similar to what we covered in the lesson, and we're going to go over that worksheet. I'll have another video for that, but that's for another time. Alright, thank you very much. Oh, and this video will be on my site, so if you do want to go back and look at it again, you're more than welcome to. I encourage this actually.